Yeah, so today we are going to solve subarray sums equals k. This is a very important topic and this has been asked in a lot of big tech companies like Meta, Google, Amazon, Microsoft, Apple, Goldman Sachs, Oracle. So this video as of date 3 Feb 2026. This is the latest data that we have from Leetcode Premium. Okay, so in this video I'm just not going to show you the two approaches that can be used to solve this problem, but also I'm going to show you the thought process, because this is what is important. ये important इसलिए है because after understanding the thought process only we can solve similar questions, we can solve all similar questions. So understanding the thought process is very important, and in my videos I am going to show you the trick, I am going to show you the observation, I am going to answer the question, oh I didn't knew this, right? That I am going to answer, and from those tricks we will find out like a certain patterns that can be used to solve problems. So this question can be solved, like a heads up I am giving, can be solved using a pattern called as prefix sum, right? So without a further ado, let's just go and explain the question. So the question says, given an array of integer nums and an integer k, return the total number of subarrays whose sum is equal to k. Return the total number, how many subarrays are there whose sum is equal to k. Okay, now first of all, what is a subarray? It says that a subarray is a contiguous non-empty sequence of elements within an array. Contiguous means लगातार, contiguous means one after the other, contiguous means एक के बाद एक. Non-empty means it should be having some value, it cannot be empty, it cannot be khali, right? And it is sequence of elements. This is the term sequence, right? So here in the example 1 1 1, can I say that this one and this one is a subarray? No, this one and this one is not a subarray, this is a subsequence. Later in the series we will have some questions which will ask us to find the subsequence, but for now let's focus on subarrays. So here the subarrays are these two guys and these two guys, these two elements and these two elements, right? Okay, now the first question, the first example is the elements in the array are 1 1 1 and k is equal to 2, right? K is equal to 2. So the subarrays will be this two and this two. Fine. Okay, whenever I see a question, my brain immediately thinks of a brute force. I don't know about others, but this is what happens to me. Unless and until I have solved enough questions that shows a pattern, right? That shows a pattern. But to understand how that pattern comes, brute force is also very important. So here I can see that what my mind says is, this is the first element and I will go from this element to the next element unless and until the sum of these two elements is equal to k, right? So here I go 1 plus 1 which is equal to k. Then I cannot do 1 plus 1 plus 1 because it is 3. Okay, I have already started from here, I will go to the next element, so I will do this too, right? I will start from here, I will go next unless and until k is equal to 2 and unless and until I reach to the end of the array. Similarly for this, I can do 1, then 1 plus 2 is equal to 3. I can increment my result with plus 1. If I go to 3, it would be 6. No, it's not equal to 3. So then I will start with this number. I'll start with this number. I'll move forward. I'll do 2 plus 1. It is equal to 5. It is not equal to k. Then I will move to this number. This number is equal to k, but this is a single number. So do we consider a single number as a subarray? Think about it. Think about it. It's a contiguous non-empty sequence. Is it a non-empty number? Yes. So the answer to the question is yes, we consider a single number as a subarray as well. So the answer for this is also 2. The answer for this is also 2. Very important to note is that the interviewer expects you to read the question thoroughly and multiple times, right? If the question seems to be a medium level questions, right? And they expect you to ask doubts. They expect you to ask doubts. If not doubts, then clarify what is the, what are the words. So it says here, right, non-empty sequence. What is non-empty sequence to a normal person? I mean, they might know, they might not know. So it is our duty to explain, right? So similarly in interview, go on explaining what the question means. Try to ask some doubts, right? Try to ask some doubts. Okay, so like the way I told the brute force approach, how will it be written? So this is a screenshot from the editorial section. Right? So like I said, we will start from the first number and we will go from the first number to the last number. Why we are doing this? Because like in the previous example, 3 was the answer, right? So we wanted to sum 3. So that's why we keep 2 pointers at the same index. Okay, so we will have a collector, accumulator called as sum, where we will just keep on adding the numbers unless and until sum is equal to k. Then we will increment our final result by 1. So we started from here, both the pointer, this pointer moves, this pointer checks, okay, if it is k, the answer increments, then again it goes again, it checks if it is equal to k, it could be 0 also, right? So if it is k, that's why we have to check for each element. We cannot break. Break is not allowed here because the last element cannot be a 0. So this is the brute force approach. Now let's talk about the optimal approach. So I'll take a big example over here. 3, 4, 7, 2, minus 3, 1, 4, 2, and k is equal to 7. Okay, what are the sub-arrays that can sum up to 7? So this guy, then this guy, this group, and then this group. So 4 groups can result into this 7. Okay, like I said in the beginning of this call, I was about to say meeting but beginning of this call, that it is a prefix. It can be solved with a prefix sum, right? So whenever you get a question that asks for you like a sub array or a sum or both, like in this question, think of creating a prefix sum. When you create a prefix sum, you will see observations that can help you solve this question. So one first tip here would be, if you see a question that has a sub-array mentioned or a sum mentioned, right? Prefix sum will be applicable to only numerics, so not a sub-array of letters, obviously, but right. So here when I create a prefix sum, the prefix sum would be 3, 7, 14, 16, 13, 14, 18 and 20. When I create this prefix sum, I have to be very, very careful. I don't want to mess up, right? So just double check this. Okay, now when you are seeing this prefix sum, if I ask you what are the 2 elements in this prefix sum, if you subtract, can give you 7 or k. So here when I see it, right, I can say that 14 minus 7 will give me k. Again 14 minus 7 can give me k, and again 20 minus 13 can also give me k. Also this 7 can give me k. So we have found 4 answers. 4 is an answer, right? But what we did, I told you to find 2 numbers so that the subtraction of those numbers is equal to k. When you see 14, right? You already know that if I do 14 minus 7, it would be 7. Then your mind says, have you seen 7 here? Have you seen 7 before in the prefix array? Yes, you have seen 7 before in the prefix array. So whenever your mind says that have you seen something before, the answer to solving it is always a hash map. Is always a hash map. Hash map is your buddy in solving a lot of problem actually. It's your buddy to solve a lot of problems. Okay, coming back. So I said like 14 I already have seen. 14 minus 7 is equal to 7. Have I seen this 7 before? Yes, I have seen it here. If I have seen 7 before, can I say that how many times I have seen 7 before, be it from here or be it from here? That increments my answer? Yes, I can say that. Yes, I can say that. Okay, so I'll just create a hash map. So think about it, okay? I'll give you like 5 seconds to think about it. What I'm saying is, once I create a prefix sum, whatever number I see in prefix sum, if I subtract it from k, the answer, does it exist before? Does it exist on the left side of the prefix array? So your time starts now. Okay, so whatever I have repeated, you might have got it again. So now coming back, so how we will create a map? So we will create a map where key is equal to prefix sum and value will be equal to number of times prefix sum has come, or frequency of prefix sum. So this is how we are going to create a map, right? Why number of times? Like I said before, if I am at 14 minus k, that is 14 minus 7 is equal to 7. I have seen 7 once. Now again, if I am at 14, I have seen 7 again. So number of times I have seen 2 times, and this creates, right? Why it creates? Because if you see, one small observation again, that the element that is creating 7 is this element, right? Is this element. The prefix sum that we're subtracting is these two, right? So the element that is in between these two, including this from the original array, will always result in k, right? Which will always, because that's how you do prefix sum, right? You increment, you keep on doing a continuous sum, right? Okay, now what you have to do is you iterate over each element, you find the prefix sum, and then voila. But there is one small edge case that we have to think of. When I say that 7 can also contribute in the result, yes, it will also contribute, because this is also a non-empty number, right? Non-empty sequence. So if I do a 7 minus k, which is 7 minus 7, it would be 0. Can I say that I have seen 0 before? If I drew a map normally, I will not be able to say. So in order to handle such edge cases, you have to add a 0 and with the frequency 1 initially. A 0 with frequency 1 initially. Okay, so this is a hash map that will get created. If you see 3 is equal to 1, 7 is 1, 14 is 2 because 14 and 14, 16 is 1, 13 is 1, 18 is 1, 20 is 1. Now once I iterate, right, because this hash map will also be created on the go. It's not like you have to create a hash map before, otherwise you will have to do a for loop twice. So you can do it in one loop also. So one by one we will create. Okay, so the first time I created, it was 0 1 by default, then it is 3 1, then it is 7 1. Every time when I create, right, what I have to do, prefix sum minus k, right? If I have seen whatever the result is already there in the map, then I can take its value and increment my result. I hope that you guys are getting what I am trying to say here. I really hope, because you just have to observe, right? Like what we did, 14 minus 7 is 7, 14 minus 7 is 7, 7 is also equal to 7, 20 minus 13 is equal to 7. If I have to go back, I ask myself a question, have I seen it? If I have the question, have I seen it, I can use a hash map. If I have a hash map, I can create a hash map with key as prefix sum and value as count or frequency, right? Okay, so this is the approach, this is the trick, and this trick for sure will be used in a lot of questions. You just have to draw prefix sum and in order to conclude with the map. And if you explain this approach to the interviewer, he will be very impressed. So coming to the solution for this question, so the solution looks something like this. Okay, so like I said, let's say I have 1 1 1 and k is equal to 2, my first example, right? So my map would be here 0 and 1, which is the default case, then 1 and how many times it is coming, 3, right? So here if I show you, right, if I go from 1 by 1, so 0 1, that is done here, then I go 1 by 1, I do a prefix sum would be 1 2 3, right? Prefix sum would be 1 2 3. First time it is 1 came, and let me draw this. Okay, 1 came and the frequency for this number is 1, right? Now I do 1 minus 2. Have I seen minus 1 before? No, I have not seen minus 1 before. So I'll just put the number and its frequency. Okay. Now I am at the second number. Second number is 2. Prefix sum is 2. Okay. So I'll say, okay, 2 minus 2, have I seen? Yes, I have seen it before, which is 0. What is the value? It is 1. So I'll just increment my results. Then I'll put the frequency 2, 1. Okay. Okay, I did 1-3 before, right? That was incorrect. Sorry, my bad. So 2, 1. Now again the prefix sum becomes 3. I will check 3 minus 2 is 1. Have I seen 1 before? Yes, I have seen 1 before. It will get accumulated in my result is now 2, and then 3 is equal to 1. I have reached the end of the array. Fine, I will just return the result. So I hope this is making sense. I'll just quickly show you some similar questions that I will be solving in my series, subarray products less than k, subarray sum divisible by k. Similarly, we'll use a hash map to see what elements are there with which are like less than k. We will divide it, and similarly we will use divisible also, right? Okay, so one small thing I just wanted to tell you, in this series I will be giving you the tips and tricks also once a pattern is solved, right? Once a good number of questions for that pattern is solved, I will give you a quick revision of all the tricks. So I am maintaining the tricks somewhere, right? Okay, so the trick here was I have to create a prefix sum array. I have to look for observations. I have to create a map, because if I want to go back, if I want to see a number already existing, the best friend is map. Then since I already know that 14 minus 7 and 14 minus 7 is coming twice, I'll have to give the value as a frequency of number of times the prefix sum has come, right? And yeah, then we are good to go. Okay, so bye for now. I think I have dragged the video a little bit too long, but I hope that this prefix sum helps you in creating the observation. Okay, bye bye.